Hello everyone, we are Team Codecrew and we are building AI keyboard. It is an intelligent layer that sits directly at the input level, making AI assistance continuous and contextual across every application that you use. So the core inside is simple. The keyboard is where all the work happens. So instead of making users switch to AI tools, we embed intelligence where the fingers already are. So we are building this in two phases. The first phase is not that ambitious. The second phase is. So the first phase is we are building a browser extension which works in Gmail, Slack, Google Docs, everywhere. Um, so we are using content scripts that monitor text inputs and run inference using on and X runtime with a quantized Llama 3.1 8B model, which is about 5 gigs. It runs in the browser via WebAssembly. So when you pause typing, we analyze context, what app, what type of input, what current text is there, and we build a targeted prompt. Then local inference is run in about 100 to 200 milliseconds, and then we display the suggestion as inline ghost text. You press tab to accept or keep trying to ignore. The challenge, however, is making local inference fast enough. So our approach is simple. First, we are using INT for quantization, which reduces the model from 16 gigs to about 5 gigs. It makes it run 3x faster. Second, KV cache optimization. We cache attention computations, which cuts repeated inference by about 60%. Third, speculative decoding using a 1B draft model to generate candidates that the 8B model verifies. This gives us a 2 to 3x speed up. We also pre-warm the model, so when we detect typing patterns that suggest a pause, for example, sentence boundaries, dropping velocity, things like that. So we start loading context early. So by the time the user actually pauses, the inference is halfway done.
Hi guys, this is Arya, and now I'm going to speak about the phase two of our application, that is the desktop app. So what we are doing here is we are building a desktop app using Tori Rust with Tori Rust as backend and React frontend, and we capture the keyboard events globally using platform APIs. For Mac OS, we have something called a CG event tab create, and for Windows, we have set Windows hookx. So these two are stuff that we are going to use to read the focus test field and detect which app is active. The Rust backend is actually deployed on llama.cpp, which is highly optimized and supports Metal on Mac OS and Code on Windows for GPU integrations. Then both the versions of share this the high overview is that both the engine share the same context analysis, intent detection, and prompt building. The local network gives us continuous personalization using LoRa adapters, low rank adaptations. We accumulate training examples. Like let's say we have 10 to 15 minutes and then we create a 100 MB adapter that modifies the model to what's your writing style. The privacy is built in, everything runs on your device. There's no API calls, no cloud storage, no keystrokes leaving your machine. It just keeps learning. Our performance targets, our keystrokes capture 1 millisecond, model inference under 100 milliseconds, and we are targeting a total latency of under 127 milliseconds. We can hit this through quantization and GPU acceleration, and we know that the main purpose of this product is that we know that keyboard hasn't evolved in 150 years, and this is quite nice of a problem statement. So we are trying to make it 100% intelligent, local, and continuous learning, no cloud dependency. That's your AI keyboard.